I welcome you for this presentation. In this presentation, we are going to discuss about web security and transport layer security. This is the overview of this presentation, that is introduction to web security, then web traffic security approaches, then secure socket layer, architecture, cryptography computations, then introduction to transport layer security, then HTTPS secure shell, followed by summary of this presentation. So what is web security? Nowadays, all of us are using the internet. That is, everyone is each and every day, everyone is accessing a number of websites. So web is now widely used by the business, government, individuals, but internet and web are vulnerable. You know the difference between the internet as well as web. Both these are vulnerable to some attacks. So we have to secure the web. For the last some presentations, we are discussing about some of the security aspects only, how to secure the mail, then file security, database security. Likewise, here now we are going to secure the web also. So what are the threats available with this, with respect to this web means? There are, we know what are the network security services available. With respect to all the service mechanisms, we are facing many challenges and issues with respect to this web security. That is, there are variety of threats with respect to integrity concept, then confidentiality, then denial of service, as well as authentication. You know all these services, what is integrity, confidentiality, denial of service, and authentications. And in order to secure the web, we need to add some security mechanisms in the aspect of integrity, maintaining the integrity, then confidentiality, how to avoid denial of service, then how to provide authentication. In all the cases with respect to web, what we are going to deal with, that only we are going to discuss here. So here from the network level, what are the security approaches available with respect to the web means? With respect to the network level, we are having these things, that is IP and IP security is there, then TCP. Then in the application layer, we are having the HTTP, FTP and SMTP. So with respect to the network level, we are having different security approaches for each and every layer. With respect to the transport level, we are having IP, then TCP, then SSL or TLS. Then in the application layer, we are having HTTP, FTP and SMTP. So with respect to the transport level, in addition to this, we are having this IP and TCP are in the network level, but in the transport level security, we will be discussing about SSL or TLS we are going to discuss. So here in the transport level, we are having the secure socket layer or transport layer security is incorporated. Those two security mechanisms are incorporated with respect to the transport level. With respect to the network level, IP security is included. So you see the shaded portion. That shaded portion only the security, web traffic security approach. Next is with respect to the application level, IP is there. We are having both connectionless as well as connection oriented protocol, that is UDP as well as TCP. Then with respect to the application layer, we are having Kerberos. You know what is Kerberos? It is authentication protocol. Then S-MIME. S-MIME we have not discussed, but it is similar to this, pretty good privacy related mail security type of thing only. So here we are having this Kerberos as well as S-MIME as the web security approaches. So now we know what are the security approaches available with respect to each and every level. That is with respect to the network level, transport level as well as the application level. Secure socket layer. Next we are going to discuss about secure socket layer. This is a transport layer security service. In the last slide, in the middle figure, you have seen that SSL is there. So secure socket layer. This was originally developed by Netscape, and version 3 is designed with the public input. And it became the internet standard known as transport layer security. So there we have seen SSL/TLS, secure socket layer / transport layer security. So the standard developed for this secure socket layer is called as transport layer security. Nowadays, this transport layer security, this layer, that is SSL is vulnerable to huge number of attacks. Nowadays we are having the encrypted form of traffic only, that is we are having the HTTPS, that is encrypted secured HTTP secured form of traffic only we are getting in, but we are having the SSL layer, that is secure socket layer, is vulnerable to some types of attack. So the standard organizations developed a standard for this SSL, and that is called as transport layer security. And this uses the TCP to provide a reliable end-to-end service, and this SSL has two layers of protocols. Let us see the protocols. So here you can see the SSL architecture. See here IP, TCP, then only we are having the SSL record protocol. In the SSL record protocol, what we are going to do, then in the above that we are having SSL handshake protocol, SSL chain cipher spec protocol, then SSL alert protocol, as well as the HTTP. So in the transport layer security, we are having the architecture, the secure socket layer architecture is this. So here we are having the connection as well as the session associated with the connection. So SSL session is a transient peer-to-peer communication link associated with the SSL session. And you know what is a session? A similar way only here in SSL also we are having session. That is, it is an association between a client as well as the server. So how we are creating a session means using some handshake protocol. TCP three-way handshake protocol, you are aware of that and you have already studied in the computer networks course. So the session is created using the handshake protocol, and here we are defining a set of cryptographic parameters, and they are shared by multiple SSL connections. So this is a main security approach, that is secure socket layer is provided, and a standard for securing this layer only we are calling it as a transport layer security, TLS. Next is the SSL record protocol services. Above this the top level we are having the SSL record protocol services. It is providing the confidentiality as well as the message integrity. That is, it uses in order to perform confidentiality, in order to have confidentiality, generally we perform encryption as well as decryption process. We apply encryption and decryption. So here this SSL uses symmetric encryption with a shared key defined by the handshake protocol, and the algorithms for encryption purpose we can use any of the algorithms, AES, IDEA, RC2, then DES, many variations are there, triple DES, Fortis or RC4. So among these some of the algorithms you are aware of that. So any of the encryption algorithms you can use in order to provide confidentiality, and here the message is compressed before encryption process. And in order to provide message integrity, it uses a MAC with the shared secret key. That is, the MAC means message authentication code. It is similar to HMAC but with a different padding scheme. So it is, you know these steps, and some of you might have implemented the HMAC also. So you know the working principle of HMAC. It is similar to that of HMAC only. In order to provide integrity, MAC is used with some shared secret key in this SSL record protocol services. Next is the SSL record protocol operation. How we know the application data, that application data is fragmented, and before encryption it has to be compressed, that we already seen. So after fragmentation, each and every fragments are compressed, then a MAC is incorporated or added for each and every compressed block, then it is encrypted. Before encryption, compression happens in SSL. So compression is there, then MAC is added, then only encryption process is performed, then append SSL record header with that. This is the SSL record protocol operation. So application data is divided into different fragments, then performing compression, applying compression operation, then we are adding the MAC, then only we are performing encryption operation, then we are appending the SSL record header. Next is the SSL chain cipher spec protocol. It is one of the three SSL specific protocols which uses the SSL record protocol. Here only a single message is used. See here in the diagram, only one byte. That is the chain cipher spec protocol. It causes pending state to become the current one, hence updating the cipher suite in use. So the size of this change cipher spec protocol is only 1 byte, and it represents 1. It is a specific protocol, SSL specific protocol, and it is just sending only a single message. So only we are having a 1 byte single message. Next is SSL alert protocol. It conveys SSL related alerts to peer entity. You know what is alert and what is the purpose of having alert. So if there is any failure or some attack might be happening, in such cases some alert is generated. For that only we are having this SSL alert protocol, and the structure of this alert protocol is level as well as alert, and level is of size 1 byte and alert is of size 1 byte. So totally 2 bytes for the alert protocol. So the severity means it gives some warning or fatal messages, or even some sound it used to use. The specific alert, fatal means unexpected message, bad record, MAC, then decompression failure, handshake failure, some illegal parameter. Warning in this sense, it just close the notification, or no certificate is provided, or bad certificate, unsupported certificate, or sometimes certificate is revoked, sometimes certificate expired, or certificate is unknown. In such cases, the warning message is given. The diamond symbol with the explanation sign, the warning symbol may be given. Some fatal alert is expected in some case of heavy failure case only we are getting the specific alert. And here we are performing compression and encryption like all SSL data. This alert protocol also we are performing this compression as well as encryption. Next is the handshake protocol. It is for the communication. That is, in order to communicate, we need the handshake protocol. So it allows server and client to authenticate each other and to negotiate encryption and MAC algorithms, then to negotiate cryptography keys to be used. For that only we are having this handshake protocol. So it comprises a series of messages in phases. That is, it is establishing a security capability. Then here we are having both the server as well as client authentication. The size of the handshake protocol is the 1 byte is allotted for the setting the type, then 3 bytes are allotted to represent the length, and n number of bytes, any number of bytes, but it is greater than or equal to 0 bytes to represent the content. So this is the structure of the handshake protocol: type, length as well as the content. See here, this handshake protocol, how these steps happen in this handshake protocol. It is for the client server communication. In order to create a session, we need a handshake protocol. So first, client is sending a client hello message to the server. So in the phase 1 is establishes security capabilities including protocol version, then session ID, then cipher suit, compression method, and initial random numbers. If the sender is sending a hello message to the receiver is replying for that hello message as server hello. Generally, if you ask hello, both of them ask hello. If we are having any telephonic conversation means also. Likewise, here also the client is sending a hello message. The meaning is the server is also interested in the communication. So it is also sending a hello message, or it is alive or active like that, in order to know that it is sending the hello message. Then in the phase 2, server may send some certificate, then key exchange and request certificate, and the server signals some end or hello message phase. That is, here you see certificate, then server key exchange, certificate request as well as server hello is done in the second phase. And in the third phase, the client is sending to the server. That is in phase 3, client sends certificate if requested, because server sends a certificate, so client also sends a certificate. Client sends key exchange, client may send certificate verification also. See here the server key exchange, so here also key exchange, certificate request is done here, so it is just giving the messages certificate verify. And in the fourth phase, it changes the cipher suit and finish the handshake protocol. That is, change cipher spec finished. The client is sending communication over, and server is also telling that change cipher spec and finished. So we have seen in the previous slide, we have seen 4 steps. The 4 steps are divided into 4 phases actually. 4 phases are explained here using the diagram. Next is the cryptographic computations with respect to this SSL. That is, it is a master secret creation. That is, it is a one-time 48-byte value is created and it is generated using secure key exchange like RSA or Diffie-Hellman public key crypto system, and then some hashing information is also used. So how we are generating the cryptographic parameters means using client write max secret, then a server write max secret, a client write key, a server write key, a client write initialization vector and server write initialization vector. Then the hashing master secret is generated. So this way only in the SSL cryptographic computations is happen, and in order to have the cryptographic computations we need some of the cryptographic parameters. Those parameters needs to be generated before used in the cryptographic computations. So that's all about this web security, and in the web security we have discussed about SSL. Next is introduction to transport layer security, that is TLS. It is the transport layer security is given in IETF standard RFC 2246. It is similar to SSL version 3, and with what are the differences compared to SSL version 3 means in record format version number, then it uses HMAC format, and then a pseudo random number function expands the secrets that is based on HMAC using SHA-1 or MD5, and it has some additional alert codes and some changes in supported ciphers also, then changes in some certificate types and negotiations, changes in crypto computations and padding. Some epsilon changes are there compared to SSL version 3, but mostly the working principle is similar to that of SSL version 3. We know HTTPS nowadays. So HTTPS means it is a HTTP in a secured format. So HTTP over SSL, that is the meaning. So it is a combination of HTTP and SSL or TLS to secure communication between browser and server. Earlier and all, we are not getting the traffic as encrypted format, but nowadays in HTTPS, the traffic is given in an encrypted manner. So it is very difficult to perform some attack, but the attackers are more intelligent and they are finding some loopholes to perform some attack. And if attack is happened in this HTTPS, because it is in the encrypted form, detecting those things is somewhat very difficult. So here this HTTPS is documented in RFC 2818, and there is no fundamental change using either SSL or RLS. And HTTPS, nowadays you see the URL you are getting into is HTTPS only rather than HTTP, and port number used for HTTPS is 443. For HTTP it is 80. So it encrypts the URL, document contents, form data, cookies, HTTP headers. What is the difference between HTTP and HTTPS means? HTTP over SSL is called as HTTPS, that is HTTP in a secured manner we are getting in, and the port number is different and it encrypts the message. Security means it encrypts. We are getting in a encrypted form only, and what are the things that is encrypting means the URL, then document contents, then data, cookies as well as the header. Next is the HTTPS use, that is in the connection initiation we are using the TLS handshake, then we are sending the HTTP request, and in the connection closure we are having two phases, that is one is the connection initiation and another is the connection closure. And in the closure we are having the connection close in HTTP record, then TLS level exchange gives the close notify alerts, then we are performing the close TCP connection. It handles TCP close before alert exchange sent or completed. Next is the secure shell, SSH. SSL and SSH, sometimes you may get confused, so you must be clear enough. SSL is secure socket layer, okay, and SSH is secure shell. First yes, secures first yes, then shell SH, so it just forms as SSH, secure shell. Always you have to remember, you don't confuse with SSL as well as SSH. It is a protocol for secure network communication. It is designed to be a very simple and inexpensive one. SSH1 provided secure remote logon facility. It is mainly used for providing security in the remote login. Then it replaces the telnet and other insecure schemes. It also has more general client server capability compared to other protocols for network communications. And this SSH2 fixes a number of security flaws in SSH1, and it is documented in RFC 4250 through 4254. So these many details are there. So we are having 5 RFCs for this for SSH 4250 through 4254, and SSH clients and servers are widely available. Method of choice for remote login or externals are in this SSH. See the format or the explanation or the format. Mainly the SSH format is the IP, then TCP, then SSH transport layer protocol is there. In the above, we are having SSH user authentication protocol and SSH connection protocol is there. IP and TCP, you are aware of that. In this SSH transport layer protocol is providing server authentication, then confidentiality and integrity. It may optionally also used to provide some compression functionalities as well. And the authentication protocol, it authenticates the client side user to the server, and in the connection protocol, it multiplexes the encrypted tunnel into several logical channels. Next, coming to the SSH transport layer protocol, this is a server authentication occurs at a transport layer based on the server or host key pairs. And here the server authentication requires clients to know the host keys in advance. And here we are having the packet exchange. For packet exchange, we need to establish a TCP connection, then only we can exchange the data. Generally, if we want to exchange data, we have to establish a connection, then we can exchange the data. And while exchanging the data, we need to identify the string exchange, then algorithm negotiation, then key exchange, then end of key exchange, as well as the service request. And it is used, how we are exchanging the packet means using some specific packet format method we are using. Using that only we are exchanging the packet. So first we have to create or establish a TCP connection. Then we are exchanging the data using some specific packet format. Next is SSH user authentication protocol. It authenticates the client to the server. Here we are having 3 message types. That is SSH message, user authentication request, failure and success. From the name itself, these message types are used for different functionality. For getting a request, then in order to represent a failure, and in order to represent the success. And authentication methods use all these things, public key, then password, as well as host-based authentication methods are also used in this SSH user authentication protocol. Next is the SSH connection protocol. It runs on SSH transport layer protocol, and it assumes the secure authentication connection, and it is mainly used for multiple logical channels. Here SSH communications use separate channels. Either side can open with a unique ID number, and here we are following the flow of data in a controlled manner. That is, here we are having 3 stages. First is we have to open a channel, then we have to transfer the data, then we have to close a channel. Generally, if we want to do anything, data transfer, or we want to exchange any message, all the time we need to first establish a connection. Here data transfer or data flow, for that data is flowing through a channel. So we have to open a channel, then data is transferred, then we have to close the channel. And here we are having 4 types of SSH connection protocol, that is the session, X11, forwarded TCP IP, as well as direct TCP IP. Next is the SSH connection protocol exchange in a pictorial representation. We have seen the protocol exchange. First we have to establish a connection, then only we have to exchange the protocol. Then that is, we have to transfer the data, then we have to close the connection. See here, first establish authenticated transport layer connection. That is, we are opening a channel. For opening or for doing any operation, we are having some message formats. That is, some comments we are having. So SSH message channel open. Then here from the server side, if it is giving a confirmation, then channel is opened. Then all the data are transferred. SSH message channel data from this to this. From client to server, the communication happens for data transfer. Finally, once everything is over, a client only establishes the session, right? So open the channel. So the client is sending a message to the server to close the channel. Next is port forwarding. That is, in this port forwarding, we are converting insecure TCP connection into a secure SSH connection. SSH is for main security purpose only. So we are in the port forwarding, we are converting the insecure TCP connection into a secure SSH connection. Here we are having this transport layer protocol. This transport layer, SSH transport layer protocol establishes a TCP connection between SSH client and server. Then client traffic redirected to port forwarding. So something is redirected. So client traffic redirected to local SSH, then travels via tunnel, then remote SSH delivers to server. Port forwarding. For that, we are having this methodology, and it supports two types of port forwarding. One is the local forwarding and another one is the remote forwarding. So local forwarding means it hijacks selected traffic, and in the remote forwarding, the client acts for server. So remote forwarding, one for another. So here client acts for the server. This is about the port forwarding in SSH. So these are the things or methodology or operations involved in the transport layer security. For that, we detailedly explained and discussed about the SSH, that is secure shell. Always you have to remember. And in this presentation, we have discussed about web security as well as transport layer security. In the web security, we have discussed about web traffic security approaches, then secure socket layer, then SSL architecture, then cryptographic computations applied to this SSL. Next is the introduction to transport layer security. There we have discussed about HTTP over SSL, that is the HTTPS. Then we have discussed about the SSH, secure shell. Thank you. In the next presentation, we will be discussing another one, security.